Okay, based on the reaction I got from students today when we were doing practice on 3D vectors, I thought I'd make a couple of extra examples for you to look at if you need them. Okay, this is like number 5 in the classwork. We have points A, B, and C, and we know that they're collinear. And we want to find the ratio that B divides A and C. Well, first of all, collinear, if I draw a picture of that, looks like this. They're in one line. It's a three-dimensional line. It's not flat, so this could go off into space somewhere, but it's a straight line. And, sorry. It should be longer. B is somewhere on this line. We don't know where because we're looking for the ratio that B divides A and C. But all three of these points are in one line. So for these to be collinear, I could divide A up into two vectors, and A to B and B to C into two vectors, and they would be parallel to each other. And if you remember the definition of parallel, if A and B are parallel to each other, because if I move B to C, it's still equal to B to C because it's the same length and going the same direction, but now it's parallel to A and B. The definition of parallel is that these two have to be the same except for one can be a multiple of the other. That means that they're going in the same direction. They may not be the same length, but they are parallel. And if I move this vector back up to here, now it's collinear. And I know these are collinear because it's given in the problem. So the first thing I'm going to do is I'm going to find vector A to B. So A to B is going to be x2, so 4 minus -1 minus x1. The y component will be 0 minus 2, y2 minus y1. And then this would be z2 minus z1, so -1 minus 3. And that is A to B. B is my second point, so this is x2, y2, z2, and A is the initial point, so it's z1, y1, and x1. Okay, and then I'm going to find the vector B to C. So vector, oops, that's an A, sorry, B to C is going to be equal to 14 minus 4, -4 minus 0, and -9 minus 1. Okay, when I simplify these, vector A to B is 5, -2, and -4. And when I simplify this vector, I get 10, -4, and that's minus a -9 minus -1, that's a plus, so that would be -8. Okay, I'm just going to put these in column form so I can line them up side by side and see them a little better. A to B, you don't need to do that, but I think it'll be easier to see here. There's A to B, and here's B to C. Okay, so if you look at this, B to C is twice what A to B is, right? 2 times AB equals 2 times AB equals 1 BC. So the ratio is 2 to 1. It's as simple as that. Okay, next. I want to use vector methods to determine the measure of angle ABC. So A is this point here, here's B, and C is halfway here. I have a better picture of it that I didn't muck up already. Okay, so I have this with the axes labeled in the traditional manner when you have 3D. The X is the forwards and backwards axis, Y is the horizontal axis, and Z up here is the vertical axis. And I'm going to label this point back here in the corner 0, 0, 0. And the reason I'm doing that is so that I don't have to deal with any negative numbers. I also need to find point A, not a vector, but a point. If I look at this, I move forward 2 because that's the side length here, none horizontally and none vertically. So that is point A. Point B, up here, I've not moved forwards or backwards, so the X component is 0, but I've moved 4 units horizontally, so that's the Y component, and I've also moved up 3 units because that is the height of the box. I also need point C. Point C, I have moved forward 1 because it's halfway between 0 and 2. I've moved 4 horizontally and none vertically. So that is point C. And if I take a look at this, if I want angle B, I'm going to need to find the vector from B to A. And I'm also going to need to find the vector from B to C. Alright, so A is the second point, so 2 minus 0, or I had to move 2 in the positive direction to get from B to A. And then 4 to 0 would be negative 4, and 3 to 0 would be, I'd have to go back 3. From B to C. If I'm starting out at 0, ending at 1, I've moved forward 1. If I'm starting out at 4, ending at 4, that's 0. And 3 to 0 is also negative 3. Okay, now I have my 2 vectors. It's really easy. From here, the cosine of the angle is going to be vector BA dot vector BC over the magnitude of BA times the magnitude of BC. Alright, so let's start with the dot product. 2 times 1 plus negative 4 times 0 plus negative 3 times negative 3. All of that is going to be over 2 squared plus 4 squared plus 3 squared times, that's the magnitude of this vector here, the magnitude of 1 squared plus 0 squared plus 3 squared. That'll be the magnitude of this vector. And let's see if we can simplify that a little bit. So that's going to be 2 plus 0 plus 9, that's 11. And in the bottom, 2 squared is 4, plus 16 is 20, plus 9 is 29. And then this is 1 squared here, and 3 squared is 9, so that'll be radical 10. So the cosine of my angle equals this, which means that the angle equals arc cosine of 11 over radical 290. And when I put that in a calculator, I get about 49.8 degrees. Alright, that's it. Hopefully you can complete the rest of your classwork and homework now a little easier.